Hello guys. So what I want to do in this video, and I don't usually do this, but I do want to do a kind of lecture over just linear functions, linear, what lines on the plane mean, etc. I am using a book for this, only to kind of organize everything. This is the book that I'm using, and I will post a link down below. I have the paper copy, so if anybody is interested in getting that book, I'll post a link to that in the description. I'm pretty sure they have it on Chegg. If not, they have other similar, editions. I'm using the 6th edition by Ron Larson. It's called Precalculus, Real Mathematics, Real People by Ron Larson. And this is going to be the first lecture over Precal. Now I have made Precal videos, and I'm pretty sure I've made like kind of similar lecture videos over certain topics in Precal. But this is going to be more of a updated kind of, I'm going to do an updated playlist of, these. It's going to be a series of videos over just going over every section. At least I'll try to go over every section, and if I can't, I will skip it. But if somebody does want me to go over something that I haven't gone over in that particular playlist, you can let me know. So these are the objectives. So the way that we're first starting this this whole section is knowing what slope is, the definition of slope, how that plays a role, on the graph, the different, and then, how that plays a role on a linear function, on a line, and the different, as well as on a linear equation, and then knowing the different types of linear equations, so like standard form, slope-intercept form, point slope form, and their relation to one another, and how to convert, from one to the other and vice versa. And then also, knowing what parallel and perpendicular slope means and how those are compared graphically and algebraically, so basically how that looks on a graph, as well as how we find it algebraically. I also wanted to add in here the idea of just what x and y intercepts are. I guess I can add knowing the difference between x and y intercepts and how to find them graphically and algebraically. So I'm going to try to go over all of this. Like I said, I'll do my best, and if I have to do a two-part kind of series, then I will, because this is a lot of information in one section. So this is for those of you that are in pre-cal. So we're going to go ahead and get started. Now, give me 1 second, everybody. There is one more thing I want to add on here. And that is, I'll do this as 3. So, knowing the what do you call them? Give me a second, guys. Okay, so I kind of made a little change here. Oh, and let me actually do this here. So the second objective here, we want to also know you know, how a linear function looks, the parent linear function. A lot of people, I mean, this is the easiest one, but a lot of people don't understand what I mean when I say parent function. A parent function means that it's just x. So like you have to know the different types of parent functions, and one of these is you know, a linear parent function is one of the ones that we have to understand right away, because they test you on this in algebra, they test you on it in pre-cal, they test you on it, you know, you have to know this for calculus as well. You have to know all your parent functions. So we're going to go over that, over a parent linear function. And like I said, yeah, like parallel and perpendicular slope, how those are compared graphically and algebraically, right? So we're going to get started. The first idea and the first thing that I want to go over is what slope actually means. So on a graph, I just want to do a little bit of a sketch here. Basically, there is this idea, and we're going to go ahead and do this. So let me go ahead and do this. So the idea of slope is basically, you know, if I want to define what slope is, so the idea of slope, this basically means that it has to be, so it says graphically, and this is how it would look graphically. Let's say we have some line, right? And like I said, this is just a rough sketch. So let me do a rough sketch here. Let's say this point, and we're going to call it some point x1, y1. And then let's do this other point, and we're going to do x2, y2. And so there's a line that is connected through those points. Let's just draw a straight line here. So we're gonna do a straight line that goes through these points, and basically I'm just gonna do like a really rough sketch. It is not drawn to scale, sorry guys, but this is just a rough sketch of a line, right? A linear you know, a line here on, and we're gonna define what slope is here. So basically, we have 2 points. One of them is x1, y1, which is right here, and the other is x2, y2. And I always like to color code these because I always like to make sure that, you know, when I do this kind of stuff, that students are not confused when I do this stuff here. And so we're gonna go ahead and do also, give me a second guys, let me color code this. Okay, so this is how this looks here. Now I'm sure we've all seen this, and I want to explain what this means because a lot of people don't understand the definition of this, and a lot of the definitions in the textbook are really, a lot of students don't understand it, and I'm going to do my best to explain what this means. Basically, let's say we have, you know, on the x-axis, this is the x-axis, and I want to, you know, kind of define here. Here's x1, and let's do right over here, or actually no, about right here. This is going to be x2, where x2 is on the x-axis. And it just means that it's the x value, so x is always horizontal, the x-axis is horizontal. And the y-axis is vertical, so y1 can be right here, so this can be y1 right here. And then over here, let's do right here, let's do y2. And like I said, it's basically about right here. And here's x1 here, and x2, like I said, it's right here. So what does this mean, right? What are we looking at? So the idea is they're basically, the definition of this is basically kind of telling us that it's basically trying to show us, you know, graphically as well as, I guess, geometrically, if you want to put it that way, the definition of slope. So let's say here is, we kind of have like a little right triangle going on here, and it kind of looks like a right triangle. And if you guys remember from like geometry, or maybe, I don't know, in high school we always learned about a right triangle. And so the definition of slope basically means that if we have these 2 points, it is really the change in the distance between this, or actually, I'm sorry, really it's the fraction, or the division between the distance of y over the distance of x. So in other words, the change in y over change in x, if you want to do that. Here is the change in y. Now, from y2 to y1, the way that we find the distance, or the length of that, we would say y2 minus y1. So y2 minus y1, right? That is the definition of that. That is how we would say it. And usually they always do it as an absolute, at least, I'm not sure, to be honest. I'm not 100% sure. I don't think it'll be absolute value. Basically, we always know that distance is the positive, but in this case we're just going to do y2 minus y1. I don't think it'll be absolute value in this case. So we do y2 minus y1, right? And that is what slope is. I mean, that's not what it is, but basically it's the division of these two, the change in y over change in x. Now, let me finish writing here. So x2 and then minus x1. Give me a second, guys. So that is kind of the graphic definition of this. And the way that we would denote that algebraically, we also call this rise over run. So when I'm looking at a point here, I'm going to go rise 1, 2, and then however much I'm running. That is my change in y over change in x. That is how we would say it. It's always, slope is always m equals the change in y over change in x, or m equals, right? Let me do it like this. M equals change in y over change in x. And we know that the change in y is this. This is my change in y, delta y, in other words. We always call this delta y. Delta y. That is what this is read as. So, that is the definition of slope. It's basically you're subtracting your 2 y terms and then putting them over your 2 x terms. So in other words, this is going to be equal to, and we're going to do y2 minus y1, and then over, and now my change in x is this. This is my change in x, right? Right here. So we're going to do over x2 minus x1, right? So that is the definition of slope, guys. And I'm going to go over some examples in a little bit. On the textbook, it says such that x1 does not equal x2. The reason why, there's a reason why they say that, and it's because we cannot have, like, we cannot have a the slope would be undefined if that ever does happen, so such that x1 does not equal x2. What this means is I can't have both of these as the same number, otherwise my slope is gonna be undefined. One second, guys. And also, these are the common errors about slope, so we want to avoid give me a second, equation errors to avoid. So these of course, the way that we would do it is there's two correct ways. This is one of the correct ways. The other correct way you can say it is if you say y1 minus y2. It really doesn't matter, like I said, over x1 minus x2. But again, I don't like the way that that's defined, because I know it can trip a lot of students up when it's said like that. Always remember, guys, that it doesn't, just like I said, it doesn't matter what you make x1 or x1 y1 equal to or x2 y2 equal to, as long as you follow this formula. It really doesn't matter. I don't even want to write that equation because it just doesn't, I don't want to confuse anybody. Also, the incorrect way to do it, do not do y2 minus y1 over x1 minus x2. This is not correct, guys. You do not want to do that, okay? Always follow this formula. Do not do this other stuff here. Just remember this formula, and you'll be okay. So now we're going to go over some examples. Let's see here. So let me just come up with some examples here. So number one, let's say they give us an example such that, you know, it tells us find the slope between each pair of find this. Let me write this down, guys. Give me 1 second. Okay, guys, so I want to go over these examples. The last example is going to be a tricky one, okay? So I'm going to do that right away, since I don't want to since a lot of people, you know, I'm pretty sure a lot of people look for challenge problems. But basically what I want to go over here is, let's go over the first one. So find the slope of the line passing through the pair of points. And actually, what I mean by the top is every slope is gonna, every one of these is a line, so they're not the same line at all. They're different lines, so that it's a different line that crosses between these two, every 2 points. So anyways, we're gonna go ahead and do the first one. We have -3, 2, and -2, 4, right? Now, like I said, the definition is that if we have 2 points, let's kind of name them again, x1, y1, x1, y1, and x2, y2. Let me do like this. It really doesn't matter what I make x1, y1 equal to or x2, y2 equal to. It doesn't matter. I can say, for example, and I'm going to do this here. I can say this is x2, and so -3 is x2, and 4 and 2 is y2, right? And I can say that the other one, -2 comma 4, is my x1, y1. We're going to go ahead and do that. So I always like to do my what is it called? I always like to list out my x1, y1, and x2, y2. So x1 is going to be -2, and then y1 will be 4. So y1 is 4, and then x2 is going to be equal to -3, and y2 is going to be equal to 2. Right? Now, I'm going to follow the formula. Now, remember, our formula is for slope is m equals, and m always stands for slope. And we always say it's going to be y2. So let's write it down. y2, or I'm sorry, y2 minus y1 over, and then it was x2 minus x1. They always say x sub 2. You don't have to say that. Just x2 is fine. Minus x1. So then we have this, right? And like I said, you're going to plug in these values here for each of these. So y2 is 2, so there's going to be 2. And be careful, since they're being subtracted, be careful. It's going to be -4, right? So we have -4. If this were a negative, you have to put it in parentheses, but it's not negative. It's going to be minus, and y1 is, it's just 4. But if it was negative, I'd have to put parentheses. I just want to point that out. Over x2, -3, minus -2. So like right here, x2 was negative, and x1 is negative as well. So I'm going to put minus and then -2, just like I was saying a minute ago. So remember, we always put minus parentheses and then the negative. So then 2 minus 4, we should already know that. That's -2. And then over, and -3, and then the negative turns into a positive. So this will be -3 plus 2, right? And so then this would be -2, and -3 plus 2, well, there's more negatives than there are positives, so it'd be -1. Lastly, you want to make sure you cancel these two out. Negative over negative is always positive, right? And also -a minus -b, this is -a plus b, right? We want to remember these rules. These are very basic rules that we have to remember. So now this will be 2, right? So our slope is 2. So in other words, m equals 2. Or we can say the slope is 2, and that is our answer. And that is how we find that for the first one. Now let's look at the second one. The second one's a little more interesting. We have number 2, right? And we're going to do, let me see here, -3 comma 7 and -3 comma 5. So -3 comma 7 and -3 comma 5. So we're going to do the same thing. Let's pretend, and I know these two are the same number, but let's all pretend this is x1, y1, and let's pretend this is x2, and then let's do, this is y2 here. So again, I'm going to write my formula, m equals, and I always like to list, and we're going to first write the formula here, so y2 minus y1 So our formula again, our slope formula, y2 minus y1 over, it's going to be x2 minus x1 minus x1, right? Now, this is going to be, so we have 5 minus, I'm going to do 7, right? I'm going to do 7 here, like that. So again, I'm going to list out, I forgot to list out my terms. So x1, negative 3, right? That's x1. y1 is 7, so let's do y1, 7. x2 is going to be negative 3. So right here. And then y2 is going to be 5, right? So you always want to make sure to list out like I'm doing here and then plug them in. So then this would be over. And it'd be negative 3, so negative 3. And then minus, so it'd be minus, parentheses, and then x1. x1 was negative 3, right? Now 5 minus 7, we should all know what that is. There's more negatives than there are positives. It's negative 2 over, and then negative 3 minus 3, well, this becomes negative 3 plus 3. Now, negative 2 goes on top. Negative 3 plus 3, well, that's just 0. Now, here is the very important part, guys, and this is where a lot of people really mess up. And I want to reiterate this, when I tutor, I always have to remind the students that I tutor that this is not equal to 0. Okay, we want to avoid that. I am like begging you guys, avoid saying that because it's wrong. When you divide by, when a 0 is in the denominator, this is undefined. So meaning that the slope is undefined, right? So basically, we always want to say this. Do not ever say that it's 0 because it is going to be wrong. So I really want to make sure that that is very clear. Of course, graphically, it's really like this. Actually, in this case, because it's in the negative x-axis, it would be like this. Let's say here's negative 3. The thing is, this is undefined. This is x equals negative 3. This is not a function, but we'll go more over that later. Let's do number 4. Or no, I'm sorry, number 3, excuse me. Number 3 is kind of similar to number 2, but it's the other way around. So let's do, let me write it down. 3, negative 6. What was it? I'm sorry, guys. 1 second. 3, negative 6, and 4, negative 6. So again, we're going to do the same process. I'm going to write the steps down here. Make sure you write. So number 1, write slope formula. So again, let's just say, again, we're going to make this x1, well, this will be y1, and let's make this x2, and this will be y2 right here. So again, I'm gonna define my parts here. So number 2 would be to define the I always forget the word. Define the I can't think of the word right now, but define the parts of the parts needed for the formula. In this case, it'd be like literally label, just like we did in the last problem. We would label our features, our parts that we need. So x1 is 3, right? It's right here. y1 is, in this case, is -6, so y1 is -6, and then x2 is 4, and y2 is -6. I forgot to write the slope formula. Let me write it down. It's going to be m equals, and we're going to do y2, so y2 minus y1 minus y1 minus y1 over, and we're going to do x2 minus x1, okay? So we want to make sure we understand that. So again, I know y2 is -6, so I'm going to put that in. So it literally just plug it in, -6. We're going to put minus, and then y1 is -6, so we're going to put -6 here. And guys, if also when you're watching the video, I mean, you can fast forward, but I would try to work it out first, but really work it out on paper. Do not do math in your head, okay? I always say that to my students because it's not good to do that all the time. So then x2 is 4 and x1 is 3, right? So we would just plug it in. Now again, this becomes -6. Negative of a negative is positive. Plus 6 over 4 minus 3 is 1. So -6 plus 6 is 0. 0 over 1, well, that's 0. So of course, this, we can say it's 0. But when 0 is in the denominator, we would always say it's undefined. The way this looks, guys, graphically, it's a horizontal line, okay? In this case, like I said, because it's negative, and I keep making that mistake, it would be below the x-axis. So this would be at y equals -6. Right, so it would be a horizontal line. But again, we're going to go over that later. I don't want to go over this graphically just yet. Now there are a few definitions to this. So this would be if m is greater than 0, meaning that if the slope is greater than 0, the line rises, meaning that it's going to look like this. This is when m is greater than 0. So these are a few features, a few kind of key points I want to make very clear. And it basically rises from left to right. So rises from left to right. Sorry, I can't write today, guys. And then so that's the first part. So the features of a slope. The second thing is that if m is less than 0, if m is less than 0, the slope, basically the line, is gonna fall from left to right. So it's gonna fall. So it's gonna decrease. So the line falls from left to right. Okay, guys. So I want to do line. For this one, it'd be the line rises from left to right. When m is less than 0, the line falls from left to right. Now, number 3 would be if m equals 0, line is horizontal. So a line with a slope of 0, let's do a line here. And if I have y equals 0x plus b, meaning that if y is a constant, y equals some constant c, let me do some constant c, then the slope is 0. So when the line is horizontal like that, the slope is 0. And it's a it's basically a constant function. And of course, number 4, if slope is undefined, meaning that if m is equal to some number like a over 0, such that a is any number, basically what this means is that if I plug in any number for a, but if it's over 0, the slope is undefined. So what this looks like is it would be on the x-axis. So the line would look, it would be a vertical line. In other words, it'd be of the form. So the form would be x equals some number b. But we know that the slope is undefined for that, because we cannot have, we're rising, or we're falling, whatever, right? Some value of a, but we're not running at all. So it's undefined. We want to remember this, guys. When the slope, when there's a number on top, it can be any number, it doesn't matter, and there's a 0 at the bottom, the slope is undefined and the line is vertical, meaning that it's going to be x equals something. We want to remember that difference of like y equals something, x equals something. This is y equals some number c, and this would be x equals some number b, meaning that for y equals a specific number, if they always give you graph y equals 3, y equals 4, it's going to be a horizontal line going through the y-axis. If they give you graph some number, some equation x equals something, it would be a vertical line. Okay, I really wanted to make that very clear. It is a lot, guys. But I want to make that very clear. Now, the other thing I want to go over in this video is the idea of and actually, give me a second. I just want to see. So basically, we already went over what slope is and how to find them algebraically and graphically. Now the other idea that I want to go over is the parent linear function. The parent linear function is always going to be y equals x. When it's of that form, we want to make sure we understand that, you know, that is the parent function. And so the way that it looks is it literally is a line that goes through the origin. The origin is always at the very center of your graph. So this would be y equals x. Now the features of this, this is y equals x. In other words, f of x equals x, right? And the domain is always what your x term is. I want to make that very clear. is the x values defined at f of x. So since this goes, forever and ever and ever from left to right, we would say that the domain of this is from negative infinity to infinity, meaning that it's all real numbers, right? And this is what we call interval notation. I do have a video over interval notation if anybody is curious as to what that means, but this is most likely a kind of review of college algebra. And as well as the range. The range you see as we go. So for the domain, like I said, we go forever on the x-axis. There's no undefined or restrictions there. That is what, that is how it goes for that. For the range, it is the same thing. So anytime, guys, I want to make this very clear. In any linear function, the domain and range is always all real numbers because there are no restrictions whatsoever. That is like the only polynomial, I'm sorry, the only type of function and where the domain and range are both all real numbers, only for linear functions. There are some restrictions, but those are for polynomials, and as of right now, I'm only going over linear. Now, the other idea is, and this is where I'm going to go ahead and define the form of a equation of a line. So this is called the slope-intercept form. And what this is, so this idea is basically going to be about, it's one of the forms of a line, and I want to make sure I make it very clear, and basically it's y equals mx plus b plus b. And this is the slope-intercept form. This is one of the forms of a linear function. In other words, we can also, or in a linear equation, right? We call that slope-intercept form. Now, this, like I said earlier, this is my slope, which is rise over run. Our slope, our m is always in front of our x for slope-intercept form, right? I mean, we can, there's certain, there's certain problems in where they give you like, first the slope, the y-intercept, and then the slope. Now the y-intercept, guys, I want to define that because it's so important for this. Give me 1 second. So the y-intercept, this is yet another type of vocabulary, right? This is gonna be, we define this as the point where the function, in other words, f of x, crosses the y-axis. So what this means is, in terms of a linear function, let's just kind of do a little sketch of this, right? I basically say, we basically in algebra say that, if you remember from algebra, we say that the the y-intercept, here's my y-axis. It's literally this point right here. Now, that is my y-intercept. But what does that mean in terms of the equation? Well, this point is actually defined as 0, comma, b. Now, guys, a lot of students confuse the difference between x and y-intercept. When we talk about y-intercept, it means x equals 0. So where x equals 0. That is algebraically. So I'm going to go over an example of this. And I want to go over this because it's so important. And this is where a lot of students just, they mix them up. So when I talk about y equals 2x plus 3, for example, and I say, find the y-intercept. Well, there are two ways to do this. We know that this is of the form y equals mx plus b, right? I can say that my y-intercept is at 0b. So in this case, this is my m, so I know m is 2, and my b is actually my y-intercept, so b is equal to 3. But my y-intercept, some people like to say y equals b, others like to name it as a coordinate. So there are two ways to say this. My y-intercept is going to be at 0, comma 3, because b is equal to 3 in this case. A lot of other people say that the y-intercept, say it's y is equal to 3, right? These are two ways to say it. Now, if I want to find it algebraically, let's just, so that is kind of one way to find it, using the slope-intercept form of an equation. The other way to find it is if I have y equals 2x plus 3, then this is going to be, so if I say find the y-intercept, well, I know that my y-intercept is when x is equal to 0. So the first step is to set x equal to 0. So I'm basically going to do this right here. So if I do that, I have 2 times 0, 2 times 0 plus 3, right? And I have y equals 2 times 0 plus 3. The next step is to evaluate. When I say evaluate, I mean arithmetically, what is this going to be? 2 times 0, so if I do, I have 2 times 0 plus 3. The first step is to multiply these two. 2 times 0 is 0. Then we bring it down, plus 3. We bring this down here. 0 plus 3 is 3. So I know that my y-intercept is y is equal to 3. Always remember, guys, when they say x and y-intercept is when x is equal to 0. X-intercept is when y is equal to 0. So now let's do my x-intercept. So let's do x-intercept now. Now x-intercept, there's only one way to do it. So x-intercept is when when y is equal to 0. Excuse me. Graphically, the way this looks on a line, right? On a line, the way this would look is, let's say I have some line here on this coordinate plane, and my x-intercept is where f of x crosses x-axis. So it doesn't have to be, in this case it's a linear function, but it doesn't have to be that. It can be any type of curve, or it can be a line, it can be any curve, but the point is, where does it cross the x-axis? It's right here. We always call this x comma 0, right? Now, algebraically, the way this is going to go, if I have, for example, y equals 2x plus 3, right? And I say to find, so if y equals 2x plus 3, find x-intercept. So the way this would go is, I'm going to write down my steps here. Step 1, set y equal to 0. So we're going to do that. So I have my little equation here, y equals 2x plus 3. I'm gonna set y equal to 0. Okay, guys, I'm gonna do that. So I'm gonna say, do this. So I have y equals 2x plus 3. I'm gonna set y equal to 0. So 0 is equal to 2x plus 3. My next step is to solve for x, okay? So 2x plus 3 equals 0. Minus 3 on both sides. 2x equals negative 3, right? So you subtract 3 on both sides, 2x equals negative 3. Notice that they're being multiplied. Divide both sides by 2. Get x equals negative 3 over 2. So this would be my x-intercept. We also like to call this a 0, right? But that is for another section. So in other words, it would be this, or as a coordinate, it would be negative 3/2 comma 0. This is my x-intercept. Okay, guys? And like I said, on the line, it would be right here. In this case, because it's negative, it'd be on to the left of x, but I'm just giving y'all a brief, like a algebraically how to do that. Now, I want to go over the idea of point slope form. So, basically, and actually, guys, I want to go over an example of how to graph a line using slope-intercept forms. So, give me a second, guys. 1 second. Okay, guys, so I think I'm going to end it here. This is going to be part 1, so I want to just recap what I went over in this video. I went over what slope means algebraically and graphically. Obviously, you know, when I did these problems, I went over kind of what, you know, how to find them algebraically, what they mean graphically, you know, and just the definition of, I mostly found them algebraically here. In the next video, I am going to go over more in depth the graphic representation of how to do slope and y-intercept. I also want to go over how to actually you know, how to find the x and y intercepts the different forms of an equation, of a linear equation, and as well as, let me think, as well as, you know, like slope-intercept, point-slope form, and also standard form. So this is going to be part 1, guys. If I rambled a lot in this video, I am sorry. It is a lot of information that I went over, so I would go ahead and go rewind the video so that you can hear me say what I said in this video. But basically that is going to be it for this video, guys. So this is going to be part 1, and with that being said, thank you so much for watching, and also please like, comment, and or subscribe. And I will post a link in the description to the book if y'all want to get it on like Amazon or Chegg. And I will see you guys in the next video. Bye, guys.